Hi everybody, welcome back. In the last video we looked at linear functions, and really linear functions are what we use for most econometrics, especially introductory econometrics. And even when we have nonlinear functions, sometimes we convert those into linear functions. And so the first one we're going to be looking at here are quadratic functions. And so just to give an example of a function, beta 0 plus beta 1 x plus beta 2, and it's the same x, but it's now x squared. So now it's got that quadratic term. And quadratic functions could take on a couple different appearances. They could be going up just initially like that with a large enough x. However, quadratic functions will often return back down and take on a shape like this. Note that it does have a maximum, so there is some point up here at which the slope and therefore the marginal effect of x on y is equal to 0. But it's really this kind of diminishing marginal effect that we're looking for. That's so common in economics, right? A 1 unit change. So we go from 1 to 2, and that's going to have a big impact on y. So y1, y2. And we have a 1 unit change up here, let's say from 11 to 12, x11 to x12. And what we can have is a very small change in y11, y12. So here a small increase in y, here a big increase in y, even though, the change in x is the same in both cases. The change in x equals 1, change in x equals 1. And this one might be the change in y might be equal to, say, 10, and the change in y up here might be equal to 1. And so, again, diminishing marginal return, or diminishing marginal return, diminishing marginal product, all sorts of economic behaviors exhibiting this functional form. So a quadratic function implies a diminishing marginal effect. A phenomenon we see very commonly in economics. For example, maybe we look at income and consumption, or we look at wages and work experience. In the beginning stages of a career, with just a few years of work experience, well, you're probably starting up here, hopefully, and it's going to increase, but as you're entering into your 50s and 60s, it's going to level off. Same thing with consumption. Once you start making more money, you're going to start increasing your consumption, but once you guys are making it super rich and you've got already a $250,000 salary, now maybe you'll increase your consumption a little bit, but it's just, it's mostly going to be going into the substitute, which would be savings and investments. So consumption is going to increase a lot at lower levels of income, but it's going to slow down at higher levels of income. So anytime you're modeling some economic phenomenon where diminishing marginal effects may exist, you're going to want to add a quadratic effect into your model. And so when we look at that, beta 0 plus beta 1 x plus beta 2 x squared. So beta 1, if this is greater than 0, it's an increasing effect. So, experience income will go up when experience increases. So that's saying beta 1 is the change in income over the change in experience, and we would expect this to be positive. So as you increase experience, you're going to have a positive increase in your income. But then the beta 2 effect, this could be positive or negative. If it's positive, we're going to have increasing effect at an increasing rate. Right? So the increasing effect is the beta 1. At an increasing rate is the beta 2. That would be like increasing returns to scale, or increasing, marginal product or something like that. What we're likely going to see is beta 2 is going to be less than 0. So we're going to have an increasing effect from beta 1, but at a decreasing rate. And that's that beta 2. So experience is going to increase income, but as you get older and older and have more and more experience, yes, it may still increase your income, but not by as much as it did back when you were, 22 years old, going to 23. Going from 22 to 23, the rate of increase in your income, this isn't age, but let's just say 22 to 23, and then over here you're going from 62 to 63. You may increase your income, but the rate is not nearly going to be as high as back, early career. So again, anytime you might have some effect similar to this, you should go ahead and think about using a quadratic effect in your equation. Okay, there is a lot of detail on logarithms and exponential functions. We may end up using some of those. Logarithms are particularly important when we're thinking about dealing with elasticities or estimating elasticities. So, how much will quantity demanded change when there's a price change, or and that. So yeah, let's write this down. Elasticities. So if you recall, the elasticity is something like the percent change in quantity demanded over the percent change in price. This could be used to think about measuring something like the percent change in employment over the percent change in the minimum wage. This is a common use for logarithms and econometrics, is to measure the effects of minimum wages, for example. I'm not going to get into all the details now. I might, if we get into some of this later on, or if any of you are going to do a project in the class where you want to think about something like this, because these do make kind of nice projects, relatively easy to do. I'll give you the the kind of the spoiler at the very end is if you do a double log function, so instead of y is equal to beta 0 plus beta 1x, you just do y is equal to beta 0 plus log of beta 1 log of x. This log is going to be, under a few assumptions, the elasticity of x on y. Again, if you do end up doing something like that, talk to me and we can I can show you some of the details, or if there's demand for the video, I'll make the video going into the details. But I just want to point out that logs also exhibit some of this diminishing marginal returns behavior. This would be something like what a log function looks like. Y is equal to log of x. This is natural log. And it crosses the x-axis at a 1. And it never actually, it gets closer and closer to 0, but it never actually hits 0. So what we call that in math is it's asymptotically bound by 0, which is another sometimes useful trait. So again, that's what a log function looks like. It also exhibits this decreasing returns to scale, or just kind of a diminishing marginal effect, what we could also call that. And then if you're ever modeling anything that is with an opposite increasing marginal effect, you could use something like the exponential function. Okay, and that's going to be increasing at an increasing rate. Okay, so again, these are, oops, those are backwards. These are y is equal to e to the x. Okay, anytime you think you might be modeling some economic phenomenon that exhibits any of these behaviors, you should consider the functional form. And, you know, if you're modeling something that looks like this, and you model it as a linear function, that's not going to give you the right the right output. So just be cognizant of really the underlying, and this is why it's econometrics and not really statistics. Is you really have to think about the underlying economic phenomenon. We can attach some of these to economic ideas like elasticities. And so always be thinking about, okay, what am I modeling? How is it going to be, you know, how, in reality, how should this effect look? Is it going to be a linear function, a quadratic function, a log function? So always having that kind of in the back of your mind when you're starting to develop these econometric models is going to be important. And again, let me know if you have questions, if you want more details about logs or exponential functions or anything else. But this is going to give us a good kind of foundation and hopefully refresher so that you're kind of caught up to speed on some math and statistics. As we go through the notes, there's going to be more refreshers as we go. But hopefully this helps. Again, let me know if you have questions, and thanks for watching.